Hello everyone, and welcome to our discussion on thermoelectric sensors. What a thermoelectric sensor is, it's a temperature sensing device that measures changes in electrical energy or electrical signal as a function of a change in temperature or as a result of some temperature. So the first one we're going to talk about is a thermocouple. And what a thermocouple is, generally, it is, of course, a temperature sensing element. And what it does, it converts thermal energy directly into electrical energy. So this type of system is self-generating. It doesn't need a battery, doesn't need to be plugged in. It generates an electrical signal all by itself. This is a result of research that was done by Thomas Seebeck back in the early 1800s when people were first experimenting with electricity. He lived in Germany, and he came up with this idea or this concept that if you have two dissimilar metals, then at those junctions, those temperatures, you have a temperature difference. And with this temperature difference and these two dissimilar metals, you can generate an electromotive force, or in other words, a voltage. So to summarize, because of these two different temperatures and two different metals, electrical energy is generated. Here's the equation for the thermoelectric thermoelectric effect. And what it says is voltage is generated as a result of a temperature difference. Now, you have a constant A, and that depends upon the two different metals that you're using. A more detailed equation looks like this. We expand it a little bit. You can see that the temperature difference, T1 minus T2, is in there. As you can see also, this is nonlinear. So it's just not a straight line. It is, in fact, a curve. One problem is sometimes we don't necessarily know what the other temperature is. If you want to measure one temperature, you need to know the other temperature also. So a lot of times what we do is we try and figure out a way of holding T2 constant. In other words, holding at one temperature, and typically that's 0. So the nice thing about thermocouples, as I mentioned before, is that they don't need to be plugged in. They generate their own electromotive force. So there's no external power that's required. And the problem we said was, what is that other temperature? If you want to measure one temperature, you have to know the other temperature. So that is done one of two ways. Either you can put that junction between those two metals in a ice water bath, and we know that ice and water, if they're well mixed, tend to stabilize right at 0 degrees Celsius. So if you know one end is 0, then you can measure the other temperature at the other end, measure that temperature difference. There's another way of doing that, and that's with an electronically controlled reference. So what you can do is you can create a circuit that will generate a reference signal that is equivalent to 0 degrees Celsius. So here are the different types of metals. We say that it takes two metals, and at those junctions, that's where you're measuring the temperature difference as a result of the voltage difference. And a common temperature or common metals that are used in meteorology are copper and constantan. They give you a really good range of temperatures. And we have standard metals and that are used for thermocouples, so they're given names. And a type T is a copper constantan thermocouple. There are other kinds that are used in industry. There's the type J, which is iron constantan. That gives you a good range also, but doesn't go to colder temperatures. And then there's type E's and type K's. Here are the constants for the type T and the type, just for the type T. I don't have alpha for the type J, but I do have betas there. So what are the advantages of a thermocouple? Well, of course, it gives you a very wide range of temperatures. Tends to be pretty rugged, pretty reliable, and they're cheap. They're not very expensive. And also they have a very good response time, very fast response time. The disadvantages are that the voltage that is generated is typically very, very low. We're talking on the order of microvolts. So, you have to have a very good way of measuring that voltage. The other thing is that also it's slightly nonlinear. We saw the equation had a square in it, but at the range of temperatures that we normally measure here on Earth, it's pretty linear. And of course, it needs calibration. The most suitable temperature range that this instrument is good for is all the way up to 1800 K, so a very large temperature range. However, where you need to measure temperatures very accurately, it's not a good instrument. It is good for measuring kind of generally not very high accuracy. So on the range that we have here on Earth, 0 to 100, it's good to within typically 1/10 of a degree Celsius. Thermocouples are typically used in industry. We have a thermocouple at just about in every house because on your gas-powered water heaters, there is an emergency switch, so to speak, that will monitor the pilot light. And when the pilot light goes out, there's no energy, no heat. And as a result, a thermocouple can measure that and can shut off the gas to the water heater when the pilot light goes out. Because it's difficult to measure microvolts, it's only generating microvolts, typically thermocouples are designed so that they put several thermocouples in series or parallel to generate a greater signal. So generally what you're doing is with each thermocouple, it generates a voltage, and you can sum those voltages to get a greater voltage, which is easier to measure. This concludes our discussion of thermocouples. We'll continue on with another PowerPoint presentation and video on thermoresistance type sensors.